Hello, very good evening, guys. Welcome to BYJU'S exam prep. Good evening, all of you. I hope everyone is good. Good evening, guys. Please do let me know whether my audio and video all good, all perfect. All right. So today, just like yesterday, we have completed the 4 years of PYQ, the recent PYQ of the subject of theory of machines. So today we'll be solving the question from the heat transfer subject. Okay, so before starting the session, I would like to ask you whether my audio and video all good, all perfect, so that we can start off the session. There are a lot many questions just like yesterday. Yesterday was like lot many problems because theory of machine, one of the important subjects for GATE examination, and approximately 27 questions were there. So today it's like approximately 22 questions. I think 22 questions are there from this heat transfer subject. So quickly do let me know my audio and video all good. All right. Okay, chaliye. So let's begin the session, and I hope so everything is perfect from my end. Yes. Okay. All right. Good evening. Very good evening, all of you. All good. Chaliye. So in today's session, we will be practicing the previous year question of the heat transfer subject, and I have taken from 2020 to 2023. That means 2021, 2022, 2023, and also I've taken both the sets. Like in your 2022, we're having two sets. We have taken both also. 2021 also have taken both the sets. 2020 also have taken both the sets. Okay. So definitely lot many questions are there, and heat transfer is one of the scoring subject. So I want you guys to be actively participating, and I've already shared the PDF of yesterday's session. I hope so everyone has downloaded that, because many students, what they do, they are actually just watching the session, but PDF is not being downloaded. So I'm sending the link on my Telegram channel also, that is Mechanical by Suraj, that you are seeing on the screen, right? In this particular Telegram channel, I have already shared. So in today's session also, after the session, I'll be sharing after like 9 o'clock. Okay, I'll be sharing this PDF on this particular Telegram channel. Okay, clear? Fine. All right. Good evening. Very good evening. Yeah, एक बार please do let me know whether my audio and video all good, all perfect, right? Chaliye. As we know that ESE means result is being out of the year 2023. So those who have qualified means you can do join our free mock interview with our expert. Every weekend these interviews are going on. Lot many students have already registered with us, and every Saturday and Sunday this mock interview is going on. So those who are not yet joined, do have a free experience this free mock test with our expertise. Okay, and we already are running with the rank up series schedule. I hope so everyone is attending aggressively. Why I'm saying aggressively? Because you'll be having 500 plus questions being done. Some question will be homework, some question will be solved on the live session. Okay, so it will be combination of the live practice, along with that some DPP, your daily practice problem. Okay, so I think we have already covered till thermodynamics, है ना? Yes, today's I think 10th, है ना? Today's 10th. So 10th मतलब अच्छा machine design तक हो गया. कल you will be going with applied thermodynamics, and day after tomorrow I'll be coming up live with theory of machine part 2. That is on Thursday. Yes, Thursday. Good evening, Mani. Good evening. So this is the app class schedule which I'm running on daily basis at 8 p.m. So 4, 5 and 9, these 3 sessions already being done. So today we'll be practicing some questions from the vibration, very important. At 8 o'clock sharp, do join in our app class. Along with that, if I talk about this PYQ series, yesterday we have covered the theory of machine. Today we'll be covering the heat transfer. 11th we'll be talking about industrial. On Friday we'll be talking about mechanics. Why I'm not taking 12? Because 12 will be having the theory of machine part 2 rank up series. Okay, so it's a complete practice week that we are having. So first question on your screen from the year 2020, from the topic of conduction. Okay, so let us try to see what is this all about. In a furnace of the inner and outer sides of the brick walls having K1 is equal to 2.5 watt per meter Kelvin are maintained at 1100 and 700 degrees Celsius, and respectively and the brick is covered with an insulating material having thermal conductivity of K2. The thickness of the insulation is 1/4 of the thickness of the brick wall. That means L2 is equal to L1 by 4. Okay. The outer surface insulation is having a temperature of 200 degrees Celsius, not 2000, 200 degrees Celsius. Then what will be, and the heat flux is already being given, then what is the value of K2? Round off to 1 decimal. What is the value of K2? Round off to 1 decimal. Everything is being given. K2 value you have to calculate. I think this is the most easy question. Thickness is being given. L1 is the thickness. This is the L1. Those are not able to see the dimension. This is L1. This is L2, right? And L2 is equal to L1 by 4. Quickly solve it. Open up your calculators and quickly tell me the correct answer. This is watt per meter square. Heat flux is given, right? So you can easily calculate. Let us see. This is the first question from the topic of conduction. We will be solving some topic wise conduction. They'll be going for the fins, then we'll be going for unsteady, then we'll be going for your radiation, then your heat exchanger, then convection. From this scenario, we'll be covering all the topics. Now, these are two slabs, composite slabs. So can we say these two are connected in series? If I try to draw the network diagram, the thermal network diagram, it is basically comprises of two resistances. This is your 1100 degrees Celsius. This is 700 degrees Celsius. This is 200 degrees Celsius. Okay. This is L1 by K1 into A. This is L2 by K2 into A. Because both are connected in series, can we say same heat will be flowing throughout the two composite bodies? Equate these two because temperature is being given, so you can easily calculate. So we can say heat transfer or heat flux is equal to 1100 minus 700 divided by L2 into K1 into A. That is also equal to 700 minus 200 divided by this is L1, na? L1, L1, and this is L2 by K2 into A, right? A get cancelled out. This is your 400 into K1 by L1 is equal to, बफर हो रहा है, एक बार चेक कर लो यार मेरे तरफ से तो आई थिंक ऑल गुड. अच्छा एक सेकंड, 1 सेकंड. अच्छा कुछ इशू हो रहा है, 1 मिनट 1 सेकंड. आप एक बार देखिए. इज माय ऑडियो ऑल गुड? वीडियो अटक गया शायद. Yes, I think there's an issue with the okay. 1 second guys, 1 second. I think video अटक गया है. हाँ, tell me the answer in the comment section, है ना? Till then I'll be sorting out what is the issue. All good? Yes, everyone? All good? Yeah, I have muted myself, so now I think it is all appropriate. Now we were talking about this one. So this is 500 into K2 by L2, and they said that L2 is equal to L1 by 4. L2 is equal to L1 by 4. So let us place it over here. So this is 400 into K1 is equal to 500 into K2 by L1 by 4. This L1 and L1 get cancelled out. This 4, this is 100. So K2 is equal to K1 by 500. I think so. Or K1 by 5. Okay. And what's the value of K1? K1 is equal to 2.5. So 2.5 by 5. This is equal to, yes, 0.5 watt per meter Kelvin. Vinod, you are getting 1.25. How you are getting 1.25? It should be 0.5. Please check. It should be, yes, है ना? Money and Vinod, please do let me know. 0.5 are we getting? चलिए बहुत बढ़िया, very good. Done. So can we go to the question number 2? I think this is all set. 0.5, very good. So the correct answer, they are saying that round off to 1 decimals. This is 0.5 watt per meter Kelvin is the correct answer. And this was a 2 marks question. Can you believe it? 2 marks ka question, easy question, guys. है ना, चलिए. That is why I told you heat transfer is a subject which is a scoring one. Heat transfer, industrial, mechanics and machine design. Let us suppose machine design अगर आप नहीं comfortable हैं, then heat transfer, industrial and mechanics, these 3 subjects are very scoring, so try to cover up these subjects. Less time, more productive. Okay, next question. Question number 2. An uninsulated cylinder wire of radius 1 mm produces the heating at a rate of 5 watt per meter. The temperature of the surface of the wire is 75 degrees Celsius when placed in an air at 25 degrees Celsius. When the air is coated with a PVC of thickness 1 mm, the temperature of the surface reduces to 55. Assume that the heat generation rate from the wire to the convective heat transfer coefficient are same for both the cases. Okay, so what is the thermal conductivity of PVC? There are 2 conditions, there are 2 cases. In case number 1, there is no insulation, right? There is something like this. This is no insulation. The surface temperature is 75 degrees Celsius and the ambient temperature is 25 degrees Celsius. Okay, right? So can we calculate the value of your convective heat transfer coefficient, because they are saying that the heat generation rate and the convective heat transfer coefficient both are same for both the conditions. Okay, both are same for both the cases, and the heat transfer rate is 5 watt per meter. 5 watt per meter. So can we say Q is equal to H into pi d into 75 minus 25. Okay, this is given as 5. H we can calculate, diameter is equal to 2 pi r. 2 pi r is 10 to the power minus 3 into 50. So from here, tell me what's the value of convective heat transfer coefficient. Those who have calculated, tell me in watt per meter square Kelvin. In watt per meter square Kelvin, what's the value of H? 5 divided by 50 into 2 pi power minus 3. Yes, are we getting 15.915? 15.915 watt per meter square Kelvin. This is the value of convective heat transfer coefficient for case number 1. And they are clearly stated that the heat generation rate and the convective heat transfer coefficient is same for both the conditions. So now what we are doing is case number 2. In case number 2, we are having a coating of 1 mm. We are having a coating of 1 mm. The radius is already 1 mm, right? Radius is already 1 mm. Okay, coating of 1 mm. So the surface temperature of the wire reduces to 55. So this temperature is 55 degrees Celsius. Ambient temperature is still same, that is 25 degrees Celsius. Okay, so now I can say Q is equal to Q by L is equal to we can say 55 minus 25 divided by, there were 2 resistances, one is your this one and second is the convective. So this is ln R2 by R1 divided by 2 pi K of the wire, K of the wire, right? K of the wire, where is that wire? 1 second, let me check. Okay, K of the wire, right? Plus 1 upon H into 2 pi R2 into L. I'm not taking, this is this one. Okay, yes. Okay, quickly, right? And not the wire, this is a PVC. This is the PVC, right? This is your insulator. So tell me what is the value of K insulator? Everything is being given. R2 is equal to 2 mm. R1 is equal to 1 mm, right? So this Q by L is given as 5. Okay, heat generation is same, so this will be 5. This is equal to 55 minus 25 divided by ln2 divided by 2 pi k of insulator plus 1 upon h is 15.92 or 915 into 2 pi into 2 into 10 to the power minus 3. Okay, solve it and tell me what is the value of K insulator. That is the final correct answer. That is a final correct answer in watt per meter Kelvin. In watt per meter Kelvin. Only thing you have to do is the calculation. Rest everything is being done. And round off to 3 decimal. They are saying that round off to 3 decimal. So you have to tell me till 3 decimal places. Quickly. What is the value you are getting? What is the value you are getting? A simple question, right? So do I need to do the calculations? देखो calculation करना है, चलो कर देते हैं. Let me do the calculation for your side. So we are having this one is equal to 5 is equal to this is 5 0 30 है ना 30 and this is ln2 divided by 2 pi k plus 1 upon 15.912 or 92 4 pi into 10 to the power minus 3. So tell me quickly. Now only thing you have to do is to do the calculations. So this is 6. This is 6. So ln 2 divided by 2 pi k plus 1 upon this value. This is 15.92 into 4 pi into 10 to the power minus 3. This is 0.2 is equal to 6. So k value is equal to this is nothing but 5. So this is 1. So ln 2 by 2 pi. This is ln 2 by 2 pi. Are we getting 0.110? 0.110 watt per meter Kelvin. Why? Because 1 upon 0.2 is 5. So 6 minus 5 is 1. So I can say ln2 is equal to 2 pi k. K is equal to ln2 by 2 pi. You will be getting k is equal to ln2 by 2 pi. Okay, and solve it, you will be getting exactly this one. Okay, so 0.110, you have to write 3 decimals. 0.110 watt per meter Kelvin is the correct answer to this question. 2 marks question. 2021 I think. This was the question asked in the 2021. ठीक है? करें आगे. Next question, question number 3 on the screen. A question from the fins topic 2021 I think, same in the same year. An infinitely long fin attached to an isothermal hot surface. Heat transfer, the transfer of heat, the heat transfer heat at steady state of Q1 to the ambient air. If the thermal conductivity of the fin material is doubled, keeping everything else constant, what is the impact on the steady state heat transfer from the fin? So it's quite easy. They are saying this infinitely long fin. So for infinitely long fin, we know the what is the formulation? Very easy. For infinitely long fin, your Q through fin is equal to under root of PHK cross section area, the base temperature into the ambient temperature, right? So I can say Q is directly proportional to root of K, right? Now what you are doing, you are doubling the value of the thermal conductivity. What will be the impact? Simple question. A, B, C or D. Q2 by Q1 is equal to K2 by K1 under root of this. So we are doubling the value here. This is root 2, option B. Option B, root 2 is the correct answer. Very good, Mani. Vinod, done. Okay. Clear hai? Done. Can we go to the next one? Chalo, next question, question number 4 on the screen. From the unsteady state, from the transient heat condition, a small bead of radius 0.5. Now, whenever you are getting question from the lumped analysis, always try to calculate the characteristic length. Okay, that is volume by area. So this is 4 by 3 pi r cube divided by 4 pi r square. This is equal to r by 3. It will ease off your calculation. Okay. When placed in a fluid of stream is equal to 20 degrees Celsius, ambient temperature of the fluid is 70 degrees Celsius, attains a temperature of 28 in 4.35 second, right? The density is given, the specific heat is given. See the units, it's very important. It's not in kilojoule, it's in SI, so no problem. If B is considered as a lumped body, the convective heat transfer coefficient watt per meter square Kelvin is, what is the value of H? Because this is a lumped body, we can directly apply the simple formation T minus T infinity upon T initial minus T infinity, that is equal to e to the power minus HA by rho V Cp into T. V by A is already LC, so we can write the initial temperature, I think it is given as 100 degrees Celsius. So 28 minus 20 divided by 100 minus 20, that is equal to e to the power minus h. We need to calculate, this is 3 by rho into R into Cp into T. Okay, solve it and tell me what is the value of h you are getting. I will be getting this value in watt per meter square Kelvin. Okay, so it will be 8 divided by 80 is equal to e to the power minus h into 3 divided by rho value is 8500 into this is our radius is 0.5 mm, 0.5 into 10 to the power minus 3 into Cp value is 400. Okay, the time is given as 4.35 seconds. So solve it and tell me what is the value of h you are getting. What is the value of h you are getting in watt per meter square Kelvin? They have given some options. What is the nearest value you are getting? Please check A, B, C or D. Do the calculation. It is logarithmic, so ln 0.1 right into 8500 into 0.5 into 10 to the power minus 3 into 400 divided by 4.35 divided by 3. Are you getting 299.95 watt per meter square Kelvin? Yes, 299.95 watt per meter square Kelvin. That is exactly option B. That is exactly option B. Okay, 299.9 something or 299.8 watt per meter square Kelvin. Option B is the correct answer. Very good. Perfect. Very good. Option B correct. Done. Chalo, next question. जल्दी जल्दी करेंगे. And this was a 2 marks question. 2 marks question था guys. Simple formula लगाना था, आंसर निकालना था. चलिए. Very good. Vinod, you are getting 289. Please do check. I think you should be getting 299 because just now I've calculated in front of you. It is exactly getting 299.95. Okay. Chalo, next question. Easy one. Easy one. Quickly. A hot steel spherical ball is suddenly dipped into a low temperature oil bath. Which of the following dimensionless parameters are required to determine the instantaneous center temperature of the ball using Hissler chart? Okay, so this question is from the Hissler chart, but they are not asking the magnitude of the Hissler chart. They are only asking you what is the value of or on which dimensionless parameter this Hissler chart will be depending upon. This temperature will be depending upon. Very easy, sir. Very good. Biot and Fourier. Biot and Fourier. If you have seen the Hissler chart, it is something like this. Here we'll be having theta by theta not theta I, right? Temperature difference, right, ratio. We'll be having something like this. This is your 1 upon Biot number and this is your Fourier number, right? Okay, Biot and Fourier are actually participating to calculate any temperature. This could be for sphere also, for a slab also, the central temperature of any sphere or slab, something like this. Okay, so by identifying Biot and Fourier number, we'll be able to calculate the temperatures, right? Okay, chalo, next question. Question number 6. A concentric tube counterflow heat exchanger, hot oil enters at 102. So hot inlet is 102 degrees Celsius. Hot outlet is होगा सब होगा भाई, आज भी होगा, कल भी जैसे हुआ था आज भी होगा, don't worry. The cold water enters at 25 and leaves at 42. And they are saying what is the LMTD? Simple question. Log mean temperature of delta Tm is equal to delta Ti minus delta To divided by logarithmic of delta Ti by delta To. Now this is a counterflow heat exchanger. Let us draw the temperature profile. This is the hot fluid. This is the cold fluid. I'm not drawing the parallel because might be it's not parallel. 102, 65, 25, 42. So this is your delta Ti, this is your delta To. Okay, quickly tell me. Delta Ti कितना होगा? Delta Ti is equal to 102 minus 42. Okay, that is equal to 60. है ना? 60. And delta To is equal to 65 minus 25. That is equal to exactly 40. Okay, so we are having very good, Vinod. 60 minus 40 divided by ln of 60 by 40. Solve it and round off to 1 decimal. 49.4 degrees Celsius. 49.4. 49.4. Are we getting this? है ना? Round off to 1 decimal, we can say 49.4 or 49.3, both are correct. Clear? Done? Is this clear? Actually, I am getting 49.333. 333 something. Okay? Clear? Done? Now, can you tell me, let us see who's going to answer to this question. If they are asking this log mean temperature difference in Kelvin, then what is your value? If they are asking the LMTD value in Kelvin, then what is the value? Let's calculate this one. क्या हो गया? I think it's all good. अरे भाई. Same. Okay, same. Sure. और 322.3 बताइए, will it be do I need to add 273 or it will be same? It will be same, yaar. It will be same. Why are you not understanding? It will be same. Why it will be same? It will be same because they are talking about temperature difference, and we know that whenever we are talking about temperature difference, आपका temperature चाहे Kelvin में हो और degree Celsius, it will be same. Okay, even though if they are asking this value in Kelvin, your answer will be still 49.3. Your answer will still be 49.3. Is this clear? Okay, done. चलिए, next question on the screen, question number 7. Okay, a question from the heat exchanger. A shell and tube heat exchanger is used as a steam condenser. Coolant water enters the tube at 300 Kelvin at a rate of 100 kg per second. The overall heat transfer coefficient is 1500 watt per meter square Kelvin. The total heat transfer area is 400 meter square. Steam condenses at a saturation temperature of 350 Kelvin. Assume that the specific heat of the coolant water is 4000 joule per kg Kelvin. Calculate the temperature of the coolant water coming out from the condenser. That means you have to calculate cold outlet temperature. You have to calculate cold outlet temperature. Let's see who's going to give me the answer. Quickly. The cold outlet temperature you have to calculate. Yes. देखो. Now, first of all, tell me which particular, one second, which fluid will be undergoing the phase change phenomena? Which fluid will be undergoing the phase change phenomena? Can you tell me? Cold fluid or hot fluid? Yes, Vinod, Mani. Cold fluid or hot fluid? Which fluid will be undergoing the phase change phenomena? Obviously, because they are talking about condenser, condensation. Hot fluid is condensing, so definitely the hot fluid will be undergoing the phase change phenomena. If I try to draw the temperature profile, it will be something like this. Very good. 350. This is your 350 degrees Celsius or Kelvin? Kelvin only. Okay. The coolant water enters at 300 Kelvin. So they're asking you this temperature, TCO. They're asking you the value of the cold outlet temperature. Okay, let's see who's going to give me the answer. Who's gonna give me the answer to this question? Quickly बताइए. नेट पे कुछ इशू चल रहा है क्या? चेक करना है. बताइए. Yes, everyone. You have to calculate the cold outlet. Now they are given some values. Overall heat transfer coefficient दे रखा है, and A is given, so we can calculate the value of your NTU. You can go for effectiveness method, E method. Now, tell me one thing: which fluid will be having C minimum? Because hot fluid is undergoing your phase change phenomena, so definitely its heat capacity rate value will be tending to infinity. So C minimum will be your cold fluid, that is equal to mass fluid to the cold fluid into CPC. So this is 100 into your 4000, 100 into 4000, right? This is the value of CC, right? This is the C minimum. So from here I can get the value of NTU. NTU निकलने के बाद you can get the value of effectiveness. Effectiveness is equal to Q actual by Q maximum. Tell me the value of this one. Tell me the value of this. A simple, easy, straightforward question. Quickly, what is the value of NTU? First of all, tell me what is the value of NTU. NTU is equal to UA by C minimum. UA by C minimum, है ना? U कितना है? U is your 1500. Area is 400. C minimum is 100 into 4000. Okay, so this will be somewhere around 12 yes, 350. Quickly. अरे देखो cancel out cancel out this one. 1 this will be 1.5. NT is equal to 1.5, right? 15 कैसे? 1.5, right? So we know that because this is C value will be equal to tending to 0 because there's a phase change phenomena occurring. Phase change phenomena, right? So I can say effectiveness will be equal to 1 minus e to the power minus NTU, right? So 1 minus e to the power minus 1.5. So what is the value of effectiveness? What is the value of effectiveness? Anyone who has calculated? Minus 1.5. 0.766, 0.7769, and we also know that effectiveness is also equal to Q actual by Q maximum. Okay, so this is 0.7769 is equal to, we can take this as your C into TCO minus TCI by C minimum into THI minus TCI. Okay, so these two get cancelled out. TCO we need to calculate. TCI is equal to 300. Hot inlet is 350 minus 300. 0.7769. Solve it and tell me what's the value of TCO. Solve it and tell me what is the value of the cold outlet temperature. Anyone? Into 50 plus 300. What is the value? Are we getting 338.84 Kelvin? 338.84 Kelvin. Are we getting this one? They are talking about nearest integer. So I can say 339. 339 is the correct answer. 339. Okay. 261 कहाँ से आ रहा है? Yes, money, Vinod, everyone. Simple, you have to do the calculation, guys. इसमें तो कुछ बचा नहीं है. Multiply कीजिए. हाँ, 338.14. Very good. है ना? So we can round off to the next integer, that is 339 Kelvin. 339 Kelvin. So we can write because they have clearly mentioned that you have to round off to the next integer. Okay, done. Clear है? चलो next question number 8 on the screen. Very easy. From radiation topic. The spectral distribution of radiation from a black body at T1 is equal to 3000 Kelvin has a maximum at a wavelength equal to lambda max. The body temperature cooled down to temperature T2 if the wavelength corresponding to the maximum of the spectral distribution at T2 is 1.2 times as that of the original value of lambda max, then what is the value of T2? Simple question. Bhai, T1 is equal to 3000 Kelvin. Let's say lambda 1 is being given. T2 we have to calculate. Lambda 2 is equal to 1.2 times of lambda 1. What's the value of this? We can use Wien's displacement law. Exactly. We can use Wien's displacement law. Wien's displacement law. That is lambda 1 T1 is equal to lambda 2 T2. Simple question. Let us take the lambda. This is 3000 is equal to 1.2 lambda 1 into T2. So what is the value of T2 you are getting? 3000 by 1.2. 3000 by 1.2. Quickly, भाई answer आना चाहिए सीधा सीधा. Yes, 2500 Kelvin. 2500 Kelvin. Very good. 2500 Kelvin. Perfect. Done. Okay. Can we proceed to the next question? Very good, very good. Chaliye, next question on the screen, question number 9th. Okay, this question from the topic of shape factor. A solid sphere of radius 10 mm is placed at the centroid of a hollow cubical enclosure of side 30 mm. The outer surface of the sphere is denoted as 1. The inner surface of the cube is denoted as 2. What is the value of shape factor? So we are having a cube, right, having a dimension of 30 mm. Okay, there's a solid sphere having a dia of 20 mm, right? This is surface 1, this is surface 2. They're asking you what is the value of F2 to round off to 2 decimals. Every time you might have seen that many number of times you are getting questions from the shape factor. That is the reason we always try to practice shape factor questions in almost every sessions if you're practicing the heat transfer subject. Okay. Chaliye, because this inside solid sphere it's enclosed in the cube, so I can say F12 is equal to 1. Okay, so we can use the reciprocity theorem. Applying reciprocity theorem, जल्दी से लगाते हैं. F12A1 is equal to F21A2. Okay, so from here F21 is equal to A1 by A2 because this is equal to 1. So calculate the value of F21. After that you can use the summation rule. So F21 is equal to A1 is 4 pi r square. 4 pi r square by this one will be 6 into A square. Okay, so this is 2 pi, r value is 10 square divided by 6 into this one will be equal to 30 square. What is the value of F21? Calculate that, and you can use the summation rule. You can use the summation rule because there are only two surfaces associated. So F22 plus F21 is equal to 1. So F22 is equal to 1 minus F21. So this is 1 minus, what is this value you are getting? Anyone who has calculated? 5 into 100 divided by 6. 0.116. 16. So 1 minus answer. 0.88. 0.8836. Are we getting this one? 0.8836, near about this value. Please check. Radius कितना है? Radius is 10 ना? हाँ, radius is 10. Oh, this will be 3, right? Some calculations will be redone over here. चलिए, what's the answer? .232. Yes, or 0.233. 0.767. Okay, are we getting 0.767? Round off to 3 decimal, 0.767, 2 decimal. So we can say 0.77 is the final answer. 0.77 is the final correct answer. Okay, 0.77 shape factor will be the final correct answer. Done. Okay, Clear hai everyone? They were asking you the self shape factor of the cube, inside surface of the cube, that is F22. Very good. Chaliye, next question. Question number 10th on the screen. Interesting. This is an interesting one from the concept of convection. Water flows through a tube of having a dia of 3 centimeter and length of 20 meter. So let me draw the diagram. This is your flow through pipe concept. Question from flow through pipe. Okay. This is inlet. This is your outlet. So this length is given as 20 meter. This diameter is given as 3 centimeter. The outside surface of the tube is heated electrically so that the subject to uniform heat flux, okay, Q dot, and actually the mean inlet and exit temperature are 10 degrees Celsius and 20 degrees Celsius, okay, that is a, 70 degrees Celsius, right. The mass flow rate of the water is 720 kg per hour. Disregard the thermal resistance of the tube wall. The internal heat transfer coefficient is 1697 watt per meter square Kelvin. Take the specific heat of water is 4179 kilojoule per kg Kelvin. The inner surface temperature at the exit. This you have to calculate. The wall temperature at the exit. चलिए try कीजिए. Quickly. A simple question, guys. इसमें कोई doubt नहीं होना चाहिए. It's an easy question. बस only you have to apply the logic. Okay. Let us calculate the heat flux because there is a uniform heat flux. Can we say heat flux will be equal to? Let me write it as Q dash. So Q dot, because Q dot we are using for heat generation. So Q dash is equal to m dot Cp 70 minus 10 divided by the area. Area equal to pi dl. Pi dl, है ना? Pi dl, right? So let us calculate this. So mass flow rate is 720 by 3600 into Cp value is 4.179. I'm writing in kilojoule, right? Into 60 divided by pi into diameter is how much? 3 centimeter. So 0.03. Length is equal to 20 meter. So from here I can get the value of this heat flux. Can you tell me what's the value of this heat flux? Anyone? Quickly tell me what is the value of this heat flux. 4.179 into 60 divided by 3600 into pi into 0.03 into 20. Are you getting 26 point? Yes, 26.604 kilowatt per meter square. है ना? We got this heat flux value. Heat flux value निकलने के बाद now we can use the same condition. Oh, because there is a convective heat transfer coefficient at the exit. So at the exit, right? Okay. So can I say that whatever heat flux is flowing, that is H into your temperature of the exit minus the temperature of the outlet? Outlet temperature. Because this heat is supplied on the wall and this wall is dissipating heat to the fluid. Fluid आपका ऐसे move कर रहा है. So ये surface पहले heat हो रहा है, then this heat, that this T2 temperature or T exit, this is your exit temperature, will be supplying heat to the, this is your bulk mean temperature at the outlet. Okay. So H value is given as how much? 1697. This is 26.604 into 10 to the power 3. Exit temperature we need to calculate. Outlet temperature is given as 70. So can you tell me what is the value of this exit temperature? What is the value of this exit temperature? This will be in degree Celsius. Round off to 1 decimal. चलिए बताइए. Round off to 1 decimal. Divided by 1697 plus 70. Are we getting 85.67? 85.68 degrees Celsius. Yes. So round out to 1 decimal, that means 85.7. 85.7 degrees Celsius is the final correct answer. 85.7 degrees Celsius is the final correct answer. Is this clear, everyone? Okay. Question easy tha, dekho. What we have to do is, this is a uniform heat flux. So we can calculate the value of Q dot because temperature is given, the inlet and outlet temperatures. Okay, we'll be having a loss of energy. वही हमने निकाला mCp delta T per unit per unit area. Okay, that will be your heat flux. Yeah, we can say your energy, uniform heat flux, and the same heat will be responsible for convecting the heat from the surface to the fluid. So we have calculated that same. Okay, fine. Chale, next question. Easy one. Match the following non-dimensional numbers with the corresponding definitions. This is your Reynolds number. Okay, this is the Reynolds number that we are talking about. Option A, option B, option C, or option D? Arey bhai, very easy question. I don't want any one of you to commit this wrong value. देखो, Reynolds number, it's inertia by viscous, so P3, P3, P1. Buoyancy कहाँ से आ गया? Buoyancy we are getting in the Grashof number. Money Q का 1 होगा 3, so B or D, it's not possible. Nusselt number, your convective heat transfer by conduction heat transfer, Prandtl is momentum diffusivity by thermal diffusivity. So SS2, SS4, 3142, 3142, option C is the correct answer. 3142, option C is the correct answer. Okay. यार देखो ये सब इज अ वेरी स्कोरिंग सब्जेक्ट और ये सब में तो गलती मत करो यार, इस सब में अगर गलती करोगे देन हाउ यू विल बी एबल टू गेट द रैंक. These are the questions where you will be saving the time and gaining the marks. गेट एग्जाम में कुछ सेट ऑफ क्वेश्चंस ऐसे होते हैं where you need to save the time and gain the marks. Okay, fine. Or this is in that particular category, right? चलो next question, question number 12. In forced convection heat transfer, Stanton number, Nusselt number, Reynolds number, and Prandtl number are related. So which of the following is giving us the correct formulation? Again, a simple save the time, gain the marks. Save the time, gain the marks. That kind of question. Which of the following is the correct formulation of Stanton number? Stanton number is equal to Nusselt by Peclet. Peclet number, and what is Peclet? That is the product of Reynolds into Prandtl. So this is Nusselt number by Reynolds into Prandtl. That is option number C. कैसे कर रहे हो यार? Option B. इतना सिली मिस्टेक करोगे तो भाई बहुत दिक्कत हो जाएगा. Do not do this kind of silly mistakes. Okay. Always remember that whenever you are feeling that कि भाई मेरे से हो जाएगा, तब एक बार टेस्ट दे दो. Go for a simple subject test. If you are able to get good marks, no problem. Not able to get good marks, identify your weakness. Identify your weakness where you are committing the mistake. Because अगर आप repeatedly doing the same mistake, then it's not possible to crack any examination, not even GATE or even A or J. कोई भी examination की बात करें, you won't be able to crack. These are some very easy set of questions. Okay, चलो question number 13. जाने से पहले Abhinav sir will be coming up live tomorrow and he'll be talking about is it possible to cover GATE 2024 syllabus timely. It's a very important topic because students are starting the syllabi. They have started the syllabi last month or last week also. So is it possible to cover all the syllabus? He'll be talking about some interesting facts tomorrow at 7:30, right? Okay, and this Sunday we are having a scholarship test. Those who are not yet availed, you can go for it. But personally, I would recommend you go for the scholarship test. Definitely, you will be going for the scholarship. But personally, I would say for more number of practice, go for that. Okay, chalo. And this is the app interface where we'll be meeting every day at 8 p.m. After this session, we'll be meeting on the app session where we'll be having that vibration K classes. Okay, chalo. Next question number 13 on the screen. The ambient air flows over a heated slab having a flat top. Okay, this is the flat. This is the air which is passing over a flat. This one. The temperature profile is given. T is equal to 300 plus 200 e to the power minus 5y. Y is the distance measured from the slab in meters. If the thermal conductivity of the air is 1 watt per meter Kelvin, and that of the slab is 100 watt per meter Kelvin. What is the magnitude of the temperature gradient within the slab? That means what is the temperature gradient at this point? So can we say whatever heat will be conducted, the same heat will be convected? You can go for this. So I can say minus kf into del T by del Y at Y equal to 0. This is, let us say I'm talking about the slab. Ks is the slab. That is also equal to minus K of fluid into del T by del Y at Y equal to 0. So what we calculate del T by del Y, that is equal to minus, and at Y equal to 0, this is equal to minus 1000, right? Minus 1000 Kelvin per meter. Okay, minus 1000 Kelvin per meter. And this is for the fluid, right? This is for the fluid I'm talking about. Fluid. This is the slab. Okay, fine. Right, so the thermal conductivity of the slab is 100. So this is minus 100 into del T by del Y at Y equal to this. We have to calculate minus of Kf of the fluid, that is 1, into this is minus 1000. Okay, so this is we are getting is del T by del Y at Y equal to 0, that of the slab, that is equal to minus plus, this is 10 Kelvin per meter. Okay, minus 10. So they are asking you the magnitude. So we can say del T by del Y, the magnitude will be equal to only 10 Kelvin per meter. Answer is 10. Okay, answer is 10. Clear? Done. Answer is 10. Okay, chaliye, next question on the screen, question number 14. Okay, interesting. This is from 2022, I think. 2022 का question है. Consider a solid slab thermal conductivity having K value is given 10 watt per meter Kelvin with thickness is equal to 0.2. Okay, of an infinite extent to other two directions. Fine. The surface 2 is at 300 Kelvin. 300 Kelvin exposed to the fluid having a temperature of 293 with the convective heat transfer coefficient of 100 watt per meter square Kelvin, right? Surface 2 is opaque, diffuse and grey with emissivity of 0.5 and exchanges heat by the radiation with very large surrounding at 0 Kelvin. बहुत easy है. Try to read the question. They are saying that what is this temperature? This temperature you have to calculate the T1 temperature, right? So can we say the heat that is being conducted, the same heat will be your convected and radiated? Yes, can we say like this? That means by using the energy balance, the amount of heat conducted will be exactly equal to the amount of heat convected plus amount of heat radiated. Okay, so this is equal to minus K into 300, or let me write it as minus, take it as positive. K into 300 T minus 300 T minus 300 by length is 0.2, right? Area is this is the area, we can take it as 1 only. This is equal to H into the temperature is from 300 to the surrounding temperature is 293. 300 minus 293 plus this will be equal to effectiveness into sigma into 300 to the power 4 minus 0 to the power 4. Why is 0? Because they are saying that it is extended to a large surface, very large surrounding having a temperature of 0 Kelvin. So we are having an exchange of heat from surface to the surrounding, right? Okay, surrounding is this one. So from here you can get the value of T. K value is given 10. K value is given as 10. So this is 10 into T minus 300 divided by 0.2 is equal to convective heat transfer coefficient is 100. Okay, this is 100 into 300 minus 293 plus effectiveness is emissivity is 0.5 into 5.67 into 10 to the power minus 8 into 300 to the power 4. Solve it and tell me what is the value of T you are getting. What is the value of T you are getting? Simple question, only calculations left out. What is the value of T you are getting? Into 0.5 into 5.67 into 10 to the power minus 8 into 300 to the power 4 plus this is 700 into 0.2 divided by 10. Are you getting 318? 318.59 degrees Celsius. In the degrees Celsius only. Oh, sorry, Kelvin. Yes, are we getting 318.59 Kelvin? Okay. So your answer they are saying round out to the nearest integer. So nearest integer will be equal to 319 Kelvin. Final answer. 319 Kelvin. This was a question asked in your 2022. Last year question ये पूछा था. This was a question from the last year. Done. 3-1. Very good, Mani. Very good. We know done. Okay. 319 because next integer is your 319. Chalo, next question. During open heart surgery, a patient's blood is cooled down to 25 from 37 degrees Celsius by using a concentric counterflow heat exchanger. So we are having a concentric counterflow heat exchanger. Okay. Concentric counterflow heat exchanger, something like this. Okay. So we are having one of the fluid moving like this, second fluid is moving like this. Okay. Water enters at 4 and leaves at 18. The blood flow rate is 5 liter per minute. Using the following properties, can you tell me what is the effectiveness of the heat exchanger? What is the effectiveness of the heat exchanger, guys? Quickly. Which fluid will be having the minimum heat capacity? Go for it. Okay. Using energy balance. Patient blood is cooled down to. So we are having hot inlet is equal to 37 and your hot outlet is equal to 25, right? The cold inlet is equal to 4 degrees Celsius and cold outlet is equal to 18 degrees Celsius. Counterflow heat exchanger. Hey, it's a counterflow heat exchanger, right? So we can say your energy using energy balance, can we say CH into THI minus THO is equal to CC into TCO minus TCI, right? CH into THI is 37 minus 25 is equal to CC. TCO is 18 minus 4. So CH into this will be equal to 2, 1, 12. This is CC into 14. Okay. So can we say CC is the C minimum? Right. So effectiveness is equal to CC into TCO minus TCI divided by C minimum THI minus TCI. Right. This to get cancelled out. So effectiveness is equal to TCO is 18 minus 4 divided by H is 37 minus 4. Okay. This is 14 divided by 33. So nearest value is 14 divided by 33, that is 0.4242. 0.4242 is the correct answer. The effectiveness of this particular heat exchanger is they are saying that round out to 2 decimals, so 0.42 is the correct answer. 0.42 is the final correct answer. Is this clear? Anna? Okay, okay, perfect. Done? Chale, question number 16 on the screen. All right, an easy one. अब देखो ये क्वेश्चन पिछला वाला क्वेश्चन था ना, बिल्कुल as it is we have to solve. There is no change in this. जो 2021 में क्वेश्चन पूछा था वही सेम क्वेश्चन आपको 2022 में भी पूछा है. Definitely language is different, but the concept is same. Consider a hydrodynamically and thermally fully developed steady flow having a fluid flow of 1 kg per second in a uniformly heated pipe with a diameter of 0.1 and length of 40. So same conditions, guys, but values are different. Concept will be same. Approach is also same. This is inlet, this is outlet. 40 meter, right? and this dimension is 0.1 meter. Okay, constant heat flux mass flow rate is 1 kg per second. Okay, so constant heat flux value is equal to 15,000 watt per meter square. This value they have given you. The bulk mean temperature of the fluid at the entrance is 200 degrees Celsius. This is 200 degrees Celsius. Okay, the Reynolds number is 85,000. Prandtl number is given 5. Thermal conductivity and specific heat of the fluid is given 0.08 and 2600. Even the Nusselt number formulation is being given. They are saying that what is the temperature at the pipe surface at the exit, right? So let us go, this is the bulk temperature, this is the TB inlet, that is 200, this is TB outlet that we have to calculate, and they are talking about the exit temperature. Okay, you have to calculate the exit temperature at the surface. This you have to calculate. So can you tell me how to proceed? Same formulation, sir. Very easy. Same formulation. Now they have given you this value. So can we say heat flux is equal to m dot Cp into your bulk inlet temperature minus the bulk outlet temperature, right, into the area, that is pi dl. So pi into d is 0.1, length is 40, this is given as 15,000, mass flow rate is given as 1, Cp is given, the Cp value is given as, where the Cp value 2600, 2600 into bulk inlet is 200 minus TB. Okay, fine. Chaliye. Oh, that would be exit minus inlet, right? Outlet minus inlet, right? TBO, क्योंकि heat is gained, heat आपका gain हो रहा है ना? TBO we can calculate. This is your inlet is 200. Chaliye, quickly calculate the value of TBO. Once you get the value of TBO, then we can use the convective heat transfer coefficient concept and get the value. So TBO is equal to, what is the value you are getting? This is pi into 0.1 into 40 into 15,000 divided by 2600 plus 200. Are you getting 272.49? 272.49 degrees Celsius. Degrees Celsius. This is the bulk mean temperature of the fluid at the exit. Okay, now they have given you the Nusselt number. Nusselt number you have given. So Nusselt number is equal to HD by K, that is equal to 0.023 Reynolds to the power 0.8 and Prandtl to the power 0.4. They have given in this particular formulation. So H value we have to calculate, diameter is 0.1, K value is, thermal conductivity is how much? 0.08, 0.023, Reynolds number is given as 85,000 to the power 0.8 and Prandtl number is given as 5 to the power 0.4. So tell me what is the value of convective heat transfer coefficient after solving this. Once you get this value, you can calculate the value of the exit temperature at the surface. Chaliye, quickly, 85,000 to the power 0.8 into Prandtl to the power 0.4 into 0.023 08 divided by 0.1. So are you getting 307? Yes. Are you getting 307.56? 0.57 watt per meter square Kelvin. Okay, so this is the convective heat transfer coefficient we are getting. Now I can apply the simple condition, because at the exit, this is the exit, right? This is the exit. This is the exit. Right? And the exit, the bulk mean temperature at the exit is, we have already calculated, that is equal to 272.49, right? Okay, and because the heat is being supplied at the wall, so first of all this surface will be heated up. This is the exit temperature, and due to this we'll be having the convection heat transfer from the surface to the surroundings. So we can say that your heat flux is equal to into pi dl is equal to h into, or let me write it like this, just directly write it like this, heat flux hi to hai, H into T exit minus 272.49. So this is given as 15,000. H value I calculated 307.57. T exit minus 272.49. Can you tell me what's the value of T exit? T exit की value 0.49. 321. 321.26 degrees Celsius. This is the temperature we are getting, 321.26. So round off to the nearest integer. So we can say 321 degrees Celsius. Even if you are writing 322, that is also correct. Okay. Is this clear, everyone? Done. A 2 marks question from 2022 paper. Clear hai? Chalo, next question. Question number 17. Very easy, I think. Yeah. A saturated vapor at 200 degrees Celsius condenses to a saturated liquid at a rate of 150 kg per second on a shell side of a heat exchanger. The enthalpy of condensation is given. A fluid having a Cp value is being given 4 kJ per kg Kelvin, enters at 100 degrees Celsius. If effectiveness is equal to 0.9, what is the mass flow rate of the fluid at the tube side? That means the cold fluid, mass fluid they are asking. They're asking you what is the mass flow rate of the cold fluid. So it is something like this. Condensation, hot fluid is undergoing a phase change phenomena. Okay, something like this. This is the process going on. This is 200 degrees Celsius. This is 200 degrees Celsius. This is 100 degrees Celsius. This we don't know. We can calculate this. Mass flow rate of the hot fluid is given as 150 kg per second. HFG is equal to 2400 kilojoule per kg, right? And we can calculate the value of T outlet, है ना? We can use energy balance. We can use energy balance. So whatever heat is being lost by the hot fluid, that is m dot h into HFG, that same heat will be gained by the cold fluid. CPC into TCO minus TCI, right? But the problem over here is we don't know the TCO and m dot C. So what we can do, we can use the effectiveness. Effectiveness equal to Q actual by Q maximum, right? And because there's a condensation going, so we can say CC is equal to your C minimum. CC is equal to C minimum, right? है ना? Is this clear? CC is equal to C minimum. अच्छा, everything is being given ना? बताइए quickly. So we can say this is equal to CC into TCO minus TCI divided by C minimum into THI minus TCI. This both get cancelled out. This value is given as I think 0.9. So from here I can get the value of TCO. TCI is given as 100. Hot inlet is 200 minus 100. So from here, what is the value of TCO you are getting? 100 into 0.9, that is 190 degrees Celsius. TCO is equal to 190. Hai? So once you are getting the value of TCO, you can place it over here and get the value of m dot C. So m dot H is equal to 150. So 150 into HFG is equal to how much? 2400 is equal to mass flow rate of the cold fluid. We have to calculate CPC is equal to 4 kilojoule per kg Kelvin into TCO 190 minus TCI is equal to 100. So from here I can get the value of mass flow rate of the cold fluid is equal to how much kg per second? How much kg per second is the answer? बताइए, how much kg per second? 150 into 2400 divided by 4 divided by 90. 1000? Yes. Are we getting 1000 kg per second? Nearest integer, 1000 kg per second is the correct answer. Okay, 1000 kg per second is the final correct answer. Clear hai? Done. Clear? Fine. Chaliye, question number 18. 18 is an interesting one. Let's try to solve it. Consider the steady state one-dimensional heat conduction for a infinite slab of thickness 2L, and they are given the diagram also. Both sides were having the same temperature, so definitely the maximum temperature will be exactly at the center line. And they are saying that the thermal conductivity is a function of temperature, that is Ct, where C value is equal to 2, that is K is equal to 2T. This is given. Okay, they are saying that if both phases are maintained at 600 Kelvin, what is the temperature at x equal to 0? That means what is the maximum temperature? Center line पे temperature क्या होगा? We can use this generalized heat conduction. One dimensional heat conduction equation. So we can say del by del x, K into del by del x is equal to minus of Q dot, right? This is the formulation. So we can differentiate this. This is K into del T by del x is equal to minus Q dot x plus C1. K is equal to 2T. So we can write it as 2T del T by del x is equal to minus Q dot x plus C1. So T del T is equal to minus Q dot x plus C1 by 2 into del x. So integrating both the sides will be getting T square by 2 is equal to minus Q dot x square by 2 plus C1 x 1 by 2 plus C2, right? This is the formulation. Now they have given some value. So at x equal to minus L, L is equal to 1 meter, right? X equal to 1 meter, your temperature is 600. Okay, so at x equal to 1 meter, your T is equal to 600 Kelvin, right? So you can place it over here. If this 2 and 2, we won't be getting cancelled now, right? So you can say 600 square by 2 is equal to, place x equal to 1. If you place x equal to 1, you will be getting, we can rewrite this equation because your heat transfer rate is 1280 kilowatt per meter cube. Q dot value is given. So let us rewrite this equation in order to have a simple understanding. Then we'll be placing the equations. Okay, right? चलो फिर एक बार काम करते. Let us try to, at x equal to 1 meter, T is equal to 600 Kelvin. Let us play. B लिख लेते हैं, है ना, 6. Okay, so we are having this to be 600 square by 2 is equal to 1 by 2 minus Q dot by 2 plus C1 plus C2. Okay, fine. All right, so from here I can say C1 plus C2 or C1 plus, let's write it like this. So this is 600 square is equal to Q dot by 2 plus 2C1 plus 2C2, right? Okay, so from here I can say that C1 plus C2 is equal to 600 square plus Q dot by 2 1 by 2. Okay, fine, clear? Just we have to rearrange this equation. This is equation number 1. Now equation number 2 will be this one, at x equal to minus 1. So at x equal to minus 1, your T is equal to 600 Kelvin. So only we are having minus C1 over here. Rest all will be same, because when you place it x equal to minus 1, this is square. So everything will be same. Only thing will be having is C1 plus C2, or we can write it like this. Will be C2 minus C1. C2 minus C1 is equal to 1 by 2 600 square plus Q dot by 2, right? This is equation number 2. So if you try to add or if you try to subtract, C1 is directly equal to 0, If you put this, if you try to solve equation 1 and 2, if you try to subtract, C1 is already equal to 0. So if C1 equal to 0, the equation is being reduced to a simpler format. I can say that your T1 square by 2 is equal to 1 by 2 Q dot X square by 2 with a negative sign plus C2, right? Okay. Clear? So now let us place at x equal to 1. Now let us place, having short of space. Let me hide myself because or else I won't be able to solve it. Okay. चलो यहाँ पे space है. So at x equal to 1, T is equal to 600 Kelvin. तो यहाँ पे we'll be getting 600 square by 2 is equal to 1 by 2. We can write plus 1 by 2. Q dot value is 1280 kilo. 1280 into 10 to the power 3 divided by 2, that is equal to C2, right? Okay, can you tell me what the value of C2 you are getting? If you try to solve it, it will be near about to, I think, 10 to the power 6. Near about to 10 to the power 6. Okay, so we get the value of C2 equal to 10 to the power 6. So place it over here. So now the equation is equal to T square is equal to minus Q dot X square by 2 plus C2. So at x equal to 0, your this will be equal to under root of C2. So this is equal to under root of 10 to the power 6, that is 1000. So the temperature at x equal to 0 will be simply 1000 Kelvin. So 1000 Kelvin is the correct answer. 1000 Kelvin is the correct answer. Okay, fine. 2 marks question tha. This was a 2 marks question that we got, right? So I think this we have calculated. बस कुछ नहीं है, बस calculation करना है. But एक चीज आपको ध्यान रखना है, this one. Students are committing mistake in this particular equation. So I hope so now you are understood. Okay, clear? चलिए, question number 19. Now we are left out with I think 4 questions. हाँ, very good. Consider incompressible laminar flow of constant property of Newtonian fluid in an isothermal circular tube. The flow is steady, fully developed temperature. It's a laminar flow. Laminar flow. Isothermal circular tube. Tell me the Nusselt number of this flow depends upon. Very good. Very good. Money. Option A. Why? Because whenever we are talking about laminar flow through pipe, there are 2 conditions that we are studying. Your constant heat flux and constant wall temperature. Okay, we are studying 2 conditions, constant heat flux and in both the conditions Nusselt number is constant hota hai. It is not depending on Reynolds and Prandtl. Okay, fine. So option A is a correct answer. Yes, namaste. No, B is not correct. It is independent of Reynolds and Prandtl. Whenever I am talking about laminar flow through pipe, what is for constant heat flux ke liye? Constant heat flux ke liye your Nusselt number is equal to 4.36 and constant wall temperature ke liye we are having Nusselt number is equal to 3.66. Okay, the value is constant, it is independent, chahe Reynolds number kitna bhi ho, no problem, your value of Nusselt number will be same. हाँ, Reynolds number, अगर if it is a turbulent flow, then it will be depending on your Reynolds number as well as Prandtl number. क्योंकि अगर मान लीजिए if this would have a turbulent flow, this would have been a turbulent flow, right? Then we know that Nusselt number is equal to, just now we have solved a question 0.023 Reynolds to the power 0.8 Prandtl to the power n is equal to 0.4 or 0.3 depending on heating of the fluid or cooling of the fluid. अब इसमें Nusselt number depending on both the parameters Reynolds and Prandtl. तो turbulent flow के लिए option B is the correct. Clear? Turbulent flow के option B, because we are talking about laminar flow. It is talking about laminar flow, isothermal, constant wall temperature. Clear? चलो question number 20th on the screen. From the heat exchanger. Consider counterflow heat exchanger with the inlet temperature of 2 fluids T1. अरे भाई बहुत easy है. Very easy question. They have given the inlet temperature of the cold and hot fluid. The heat capacity rates is being given, right? So we can say C2 is your C minimum. So we can say effectiveness is equal to Q actual by Q maximum, right? So this is 0.5, it is given in the question. Q actual we need to calculate. What is Q maximum? That is C minimum into THI minus TCI. है ना? Fine. So what is the value? Q actual 0.5 into 400 into HI. This is 350 minus 300. चलिए, this is equal to 0.5 into 400 into 50. Quickly, what is the value? Yes. And you have done me in kilowatt. Kilowatt में बताना है. Kilowatt में बताएंगे. So we are having 1, 2, 3. So this is 0.5 into 4 into 5 kilowatt. This is nothing but 20. This is 10 kilowatt. 10 kilowatt. Are you getting 10 kilowatt? Yes. Done. 10 kilowatt is the final correct answer. Okay. 10 kilowatt is the final correct answer. By 4 into 5, 20, 20 into this 0.5, that is 10. Chaliye, bahut badhiya. Next question. 21st question. A cylindrical rod of length h and diameter d is placed inside a cubic enclosure. So we are having a cube having a side of L, right? Inside this we are having a cylinder having a length of h and a dia of d. You have to tell me what is the shape factor of S denote the inner surface. That means let's say this is surface 1, this is surface number 2. What is F22? बहुत easy है. Question देख के आप आंसर बता सकते हैं. Without even solving also you can get the answer. देखो, you cannot have A, you cannot have B, and definitely it is, what is F22? F22 is equal to 1 minus F21. F21 कैसे निकलेगा? Reciprocity theorem. F21 is equal to A1 by A2. What is A1? A1 will be equal to pi dh plus your pi by pi d square by 4 into 2, because there are two circles. Pi by 4 d square divided by 6 L square. Okay, so this is equal to 1 minus pi dh, very good, pi d square by 2 divided by 6 L square. So we are getting option D as the correct answer. Option D. Okay, chalo. Next question. Next question. Last, I think. This is the last question. Question is very easy. A very large plate of thickness D and thermal conductivity K is cooled by a stream of air having 300 Kelvin, having a heat transfer coefficient of H as shown in the figure. The central line temperature of the plate is Tp. The following cases can be lumped. Achha, they are talking about which of the following is the case of lumped heat analysis, lumped parameter model. That means your Biot number should be less than 0.1. So there are 4 cases. This is an MSQ problem. This was an MSQ question in 2023. Okay, let's see this year's gate question. By simple hai, we know that characteristic length will be equal to d by 2. Characteristic length will be equal to d by 2. Because this is a plate, this is a plate, this is something like this. ये आपका, this is the plate, something like this. Okay, fine. This is your D, this is L, right? This is L. So we can say LC is equal to volume by area, right? Volume कितना होगा आपका L cube, right? Divide by area कितना होगा आपका L into L. Okay, no, not L cube, L into D. L into L into D, right? This is L into L plus L into L. So this is equal to D by 2. That's it. D by 2 aa gaya. So now we are having 4 options. We calculate Biot number one by one. So at option number A, we are having H is equal to this, K equal to this. This is 1 mm. So for option A, Biot number is equal to HLC by K. H value is 100. Into LC is D by 2, D is 1 mm, so 0.5 into 10 to the power minus 3 divided by K value is 1000. So this is somewhere around 0.5 into 10 to the power minus 4 less than 0.1. So this is a lumped parameter. Let us go with option number B. Let us go with option number B. Option B, Biot number is equal to HLC by K. H value is 100. 100 into, what is the diameter? Diameter is equal to 1 meter. ठीक है, तो मतलब 0.5 divided by K value is 100. So this is equal to 0.5, which is greater than 0.1. So this is not a lumped body. This is not a lumped body. C option देखते हैं. Biot number is equal to HLC by K. H is 1000. LC is D by 2. Diameter is again 1 meter. 0.5 divided by K value is 1. That is equal to 500, again greater than 0.1. This is also not a your lumped body. Option D. Biot number is equal to HLC by K. H is 100. Diameter is 1 mm. 0.5 into 10 to the power minus 3 divided by K value is 1000. This is 0.5 into 10 to the power minus 4, which is less than 0.1. So this is a lumped body. So answer is A and D. A and D is the final correct answer. So for A and D options, we are having the lumped parameter model. We can use lumped analysis. Okay, clear? So these are all the questions from 2020 to 2023. 4 years of questions हमने पूरा का पूरा solve कर दिया in this particular session. Okay, so along with that, we have already started this rank up also, rank up series on our YouTube, जिसमें 500 plus practice questions. These are new questions. These are not PYQ. ठीक है, already started from 3rd October. Right. If I talk about the app classes, now we'll be starting this vibration. Not here in our app class. So 8 बजे बिल्कुल 4 मिनट बाद we'll be starting our class on our app. So vibration topic है. Do join there also. Right. After that, if I talk about this series, we have covered theory of machine, heat transfer. Tomorrow we'll be talking about the industrial engineering 4 years of questions, the PYQ series, and then we'll be going for the next session. Okay, so this is it from my side, the crash course. I hope so you have joined. If you're not yet joined and you are willing to crack GATE examination, you can do call to this number which is available on the screen. Okay, so I'll be sharing this PDF of this session on this Telegram channel. You can download from there also. Right, fine. And that's it from my side. Hello. Too early for the next class, but I would say that you can do join our next session that is on vibration topic on our app at 8 p.m. That means after 3 minutes we'll be starting off with this particular topic. Okay, so you can do join there also. Fine. So thank you. Bye bye. Take care. Stay safe and enjoy your day with BYJU'S exam prep. Thank you guys. Bye bye. Take care.